All right, we got a system of equations and they're not linear, especially the second one. So we need to find where they cross. Yes. So that just means that you have to use a substitution from the linear function on top and then plug it into the bottom equation. Now you have one variable, one equation. Find the value, but make sure that you follow the direction. It said y is greater than 0. So if you get a negative y, just ignore it. So let's rewrite the top equation. I'm gonna say they want y. So I was about to say y equals negative 3x, but instead I'll say x, okay, 3x equals negative y. We'll want to write this in terms of y so we can plug it into the second equation and we don't have to look for another variable at that point. So I'm going to divide both sides by 3 and that result x equals negative y over 3. This is what we're going to plug it into the second equation that I believe is what's that called? An ellipsis? Yeah. So negative y over 3 get plugged in again in x, but you have to square that. Plus 2y squared is equal to 76. All right, let's distribute the power of 2 for both negative y and 3, and you're going to get y squared over 9 plus 2y squared equals 76. Okay, so you combine the like term here. 1 over 9 plus 2 will give you, you know that's 18 over 9, right? And y squared over 9. You add them up and you get 19 y squared over 9 equals 76. Now you might just try to multiply these numbers, but there's a faster way. Why don't you divide first? Because you know that 76 is a multiple of 19. And then now multiply 9. Because this way, you don't need to use calculator. We got y squared equals 36. Then y can equal to two things. Plus or negative 6. Because when you square root the square, I told you before that square root of a square is the absolute value of y. So you can have plus or negative 6. Okay? But we said it in the direction that y has to be positive. So we'll just keep the positive 6. And that's your answer.